All right, we are in AP Calculus. We are on lesson 3-2. Today's date is Monday, October 7th, 2019. Today's lesson is about, again, graphical analysis for basically the whole unit. It goes graphical analysis and then it goes analytic analysis. Graphical analysis is kind of fun because you actually get to look at a picture of a graph, and then analytic analysis is, I'm going to give you an equation, you have to figure out all this stuff now without a graph. So get ready to have your hands tied behind your back with no picture of a graph, because that's where we're heading. We are totally doing that dance again this unit. I'm going to get my headband and stuff out. I'll do our dance. We'll put on some music. It'll be great. Yeah, so I learned how to do the dance correctly. Someone else showed me as a teacher. We'll see. Do I do it today's lesson? No, I do it tomorrow's lesson. You'll see the dance tomorrow. All right, so, I'm gone tomorrow.
Sit down.
Oh, no. Okay, so I'm going to record this video. Maybe I can record a picture of me dancing and input it in there. I totally can do that. It's not that hard. But yeah, you'll have to know the dance, and I'm going to make sure that all of you dance. I'm going to put it in the sub-lesson plan. Make sure that they actually get up and dance, and if not, tell me. Make sure you're dancing. He'll or she'll be watching. I think it's Miss Holler again.
No, I thought
She's always she's in Good Always Class.
Is she there tomorrow as well?
I thought so.
Okay, then it's going to be that cool guy again, I'm guessing.
Oh, okay.
Anyway, let's do the notes today. Reading a graph of f and f prime. So this is purely review from Friday. Let's see if we remember how to do this. If I have a graph of f, in terms of notation, what are heights? In terms of f prime or f double prime or f triple prime or f quadruple prime, heights are just f. Everyone write it down. My f needs to be a little bit better for my handwriting. That's a little bit better. Heights are just f, which is universally true. Here's the trick. If you're ever asking what your heights are, they're whatever is labeled here. What are the heights for this graph going to be?
F. Prime.
I said first.
So you can label that now if you want. I'm going to come back to it and ask you again, and you'll have to tell me without looking. Okay, what are slopes of this thing if heights are f?
F prime.
F prime, because I take the derivative of whatever the heights were. So I have f prime here. What about concavity?
F prime prime.
F double prime or f prime prime. There they are. This is just purely review. We're just making sure we got this. All right, now without looking your notes, looking straight up. Don't look at your notes, Psycho. Looking up. What are the heights of this graph?
F prime.
F prime, because that's what's labeled here. It says f prime. And therefore, I just take the derivative each time. That means slopes on this graph are going to be
F double prime.
f double prime, and concavity is going to be
A jerk.
a jerk. F triple prime, he's our jerk. We don't care about jerks in this class. Cross them off. We don't care. We don't care about the concavity of the graph of f prime,
Sounds dope.
which is kind of nice because there isn't any concavity, or the concavity is 0, I guess. Okay, so there's our review. Let's talk about our objective today. Can someone read our objective? We forgot to do that. All right, so how many of you have even heard of the term critical values? Woo, new stuff then. Critical values. So let's give the definition of f increasing and decreasing, and then we can talk about critical values on the very back. I guess it makes maybe more sense to switch these later. Anyway, function increasing. This is just a flashcard, a definition you have to memorize. Here we go. The definition of f increasing, and I don't like writing it. Can we all rewrite it like this? Let's write f increasing. This is the better way to write it because it's nice and fast and you don't have to write function increasing. Okay, so f increasing, that's the notation that I use. And the definition of f increasing is as follows. It's where f prime, not f, but f prime, and not f double prime, is greater than 0. Memorize it.
That's the slope.
Exactly, because
even on graphs of f prime?
so that's the whole point. It doesn't matter what graph I give you, because you now know how to convert into the notation. Since you now know how to convert to notation, just look at the notation. F prime, there it is. So I'm talking about slopes. Where's the slope greater than 0? On this one, where are the heights greater than 0? That's why I've taught you how to get back to the notation, because this notation, f prime, match that up with the notation up here. Am I talking about heights or slopes? Well, I don't know. Convert to the notation, and then you'll know. So back here, for f increasing, it's f prime is greater than 0, and that means the slope on a graph of f. And f decreasing, take a guess, shout it out.
F less than 0.
F what?
F prime is less than 0.
F prime is less than 0. You just have to have this memorized. And we haven't been doing the speed sheet, the Quizlet as much as we should be, but we need to get in the habit of giving like that speech sheet maybe once or twice a week, reviewing everything that you've done. And maybe if I reset it and then compete with you guys again. Claire gets really mad. I'm in first place though. Because it's way harder now that we have so much stuff. Okay, we have these memorized, right? We have one more thing to memorize at the very end, but let's go ahead and play with these.
So on a graph of f double prime, you can't figure out if the function's increasing, right?
Not unless I give you an initial value and work backwards after unit 5. But for all of this unit, you are correct. Because we don't know how to go backwards, we haven't hit unit 5, we can only find f increasing or decreasing on these two graphs, which is why I didn't give you a graph of f double prime. All right, so here's a graph of f. And I took that graph and took its derivative, and there it is. Bless you, bless you. So you need to tell me roughly where is this graph increasing and where is it decreasing? Increasing, decreasing. Where is it increasing? Well, what does it f increasing mean? Shout it out. F increasing is where f...
X greater than 0.
Okay, so f prime is greater than 0. What is f prime on this graph?
The slope.
The slope. So where is the slope greater than 0?
Oh, like over, like past, like on top.
The x is greater than 0.
Yeah, so let's write all this stuff down. You guys are getting it. F prime is greater than 0. That's the definition. So it's really talking about, you have to convert this now, it's talking about slope is greater than 0. We've converted it over. And then you've told me the slope is greater than 0 for which x coordinates? For x
X is greater than 0.
greater than 0. There's another way to write this. You can write this from 0 to positive infinity. There are two ways to write this. You can say this one or this one. They're both correct. Different notation. This is in interval notation over here, and this is, I think it's just called inequality notation, I would guess.
When you do interval notation, should you do the little square brackets, or does it not matter?
It does not matter for the AP test. It matters for me, though. I want you to be correct. This is how you do it. You need to say it's not increasing at 0. At 0, it's neither positive nor negative. It's equal to 0. If it was this for the definition, then it would be something else. It would be a square bracket. But because f prime is greater than 0, I have to do a parenthesis here, not a square bracket. And by the way, whenever you have an infinity, you can never be equal to infinity. You can only approach infinity. So you can never do a square bracket for infinity.
So a curved bracket means it does not include an x well.
Yeah, if you guys want to write that off to the side, it doesn't matter. You're still going to get the points right on the AP test. They'll never take off points for this, as far as I know. The last 3 years, they've never done this. If you have parentheses, that means that's less than or equal to, or an empty dot, not a closed dot, not equal to, not equal to. And on the other side, if I have square brackets, those match up with less than or greater than, equal to, less than equal to, greater than equal to. It's a filled point or a closed point, and that's equal to. If you ever forget this, and I don't care if people know this, but it's right there, very right side of the cabinet, it's all of the different possibilities that you can have. All right, so where is f decreasing? Someone give me the definition of f decreasing.
F prime is.
There it is, f prime less than 0, which can now convert f prime. On the graph of f, what is f prime? Okay. So slope needs to be less than 0. Where is the slope less than 0 on this graph? X is less than 0, or in interval notation from
0.
Well, you have it correct. You usually go from the left to the right. But yeah, from 0 to negative infinity or from negative infinity to 0. Perfect. Those are the both possibilities. Nice. All right.
So the other one would be the same thing, right?
It's not,
Double
because I
prime.
have a different graph now.
It's a double prime.
So we'll talk about this. So now I have a graph of f prime.
F
What is the definition of f increasing?
double prime equals. No, it's greater than 0.
Nope. You rewrite it again. It hasn't changed. The definition is still right there.
Oh, F prime.
Yeah. So that was your question, Gio. And it's still the same. It's still f prime. F prime is greater than 0. The definition does not change. But now the conversion of what this means does change. This is no longer slope. What is f prime now? Height. That's the key difference here. So it's where height is greater than 0. Where is the height greater than 0?
X greater than 0.
Where x is greater than 0, and I can say that from 0 to infinity, which is pretty cool. The reason that these two match up here, that the left and the right, in terms of this line, are all the same is because this was the exact same graph. I took this same graph, took its derivative, and that's what it looks like when I take the derivative. If I took the derivative correctly, these should all match up. These should also all match up. That's how we can check our work. That's not how you get the answer. That's how you check your work. All right, definition. F decreasing. What do we have? F prime, Sego, less than 0. And convert. What is F prime on this graph of F prime? Height. So height is less than 0. Or what do I have? Yeah, height is less than 0. Height is less than 0. So now I ask you guys, on this graph, height is just these lines right here. Where's the height less than 0? The height is less than 0 down here. In terms of the x-coordinate, I have to go from here to the left. There it is again. X needs to be less than 0, which matches up so far. We're checking our work. Yes, we're doing it correctly. And then the other way that I write is from negative infinity to 0, not including 0. All right, that's our basics for F increasing, F decreasing. So far, so good?
Mm-hmm.
Let's go on to critical values.
Are these like maximums?
They are, yeah. Or I should say they can be. They have the possibility of being maximins. I will talk about maximins more tomorrow. So, function critical values is the full name for this. The way that I abbreviate this is F, lowercase f, capital C, capital V, FCV. So you're looking for CVs. You're looking for critical values of the function. And the definition of that, well, you have two possibilities. Here's the two possibilities of the definition. Possibility 1. Do you remember this arrow?
No.
F prime is equal to 0. That's half of the cases. Well, if I'm actually being mathematically correct, that's probably where I have, it's about half. In the AP test, it's usually a little bit more than half. The other possibility that will cause you to have a FCV, a critical value, is where F prime does not exist. Those are the only two possibilities that will give you FCVs. And every single time that you see them, it will always be a CV. It will always be a critical value. So, notice that everything in today's lesson, we're talking about F prime. None of our definitions were F double prime. All of our definitions were only dealing with F prime, which makes it kind of easy to remember. This will eventually change, and some of our definitions in the future will be F double prime. But for now, all of our definitions are with F prime, the first derivative. So, this is a graph of F. What does F prime mean on a graph of F? Is that height, slope, or concavity? It's slope. So, when I'm talking about critical values on this, pay attention to slopes. Specifically, where is the slope equal to 0, and where does the slope not exist? Find them all. Where is the slope equal to 0? Where does the slope not exist? Do it now on your own. On this graph, where does the slope equal to 0, and where does the slope not exist? You should find 3 CVs on here. Yeah, go ahead and circle them. And then check around. Are you getting them? Did Arrow get them already? Can't spell graph. All right, so what you should have found is we have a slope of 0 right here, a slope of 0 right here, and a slope not existing at a sharp corner because, again, to take the derivative, it needs to be differentiable. A function is not differentiable where? There's 3 things. Holes are part of a giant category called discontinuities, and our last one, which is vertical asymptotes. Good. Good review of Unit 1. Cool, there they are. So those are where you have FCV. So we'll write them down a little bit more formally now. You'll say this is an FCV, and then why? It's an FCV because F prime is equal to 0. Over here, this is an FCV. Why? Because f prime is equal to 0. This is also an FCV. Why? F prime D N E. Good. I can kind of prep you for. No, I'm not going to do it. That's all I have for you guys today. Are there any questions before the end of the lesson?